Sam, nice to hear from you, pal. Listen, I think I'm gonna make sense to send a video to explain that when you, let me put this whiteboard up. When you conduct a test, a two-tailed test to see if two things are equal, if two groups are equal, if their means are equal, right? You're doing a two-tailed test, okay? You set your values, right? If it's a 95, if your alpha is equal to 0.05, let's say, right? You want 95% here in the middle. So this would give you 1.96, let's say, right? Okay. So when you do the test to see the null hypothesis, in our case, we said that mu1 equals mu2, and then the alternative is where mu1 does not equal mu2. So it could be bigger, be greater than or less than. One could be greater than, we don't know which one's going to be bigger, right? We're testing to see if the two are equal in a sense, right? Okay, so we're testing this. Okay, so in this particular test, right, when one is bigger than the other, you've really passed a more stringent test than if you were actually testing if mu1 is greater than or equal to, let's say, mu2. Let me situate this right here. Actually, let me get this example. This instead. Less than or equal to in this case, okay? So that would be our null, since it contains the equality. And our alternative is mu1 strictly greater than mu2, let's say, right? Okay, so in this particular test, you've got a one-tailed test with the whole level of significance, right, being in here, right, not split between two sides like it was over here. So this is even pushed even further this way than this number. So this would be like 1.645, I believe, right? So it's easier to test if one is bigger than the other, in a sense, right? All the tail lies on one side. If you have a sense of one being bigger than the other, and you're trying to test that specifically, is easier than trying to see if they're not equal, right? With this situation up here, right? Because here you're further away from zero to get the rejection of the null hypothesis. Right? Does that make sense? I hope. Yeah, I think there was, let me see if there was another question. Just 2 seconds. Sure I address everything. Yeah, I mean, you could state the direction, or you don't have to. I mean, if you show it in your results, you don't have to necessarily state it specifically, but people will see that this mean is this mean is this. They'll know which one's bigger. You know what I mean? When they know that the two are not equal. So advanced statistics books, multivariate techniques. I don't know any specific books, to be honest with you. I'm sure if you just do a Google search, and there's probably some decent ones out there. I don't teach any classes using books specifically. I use my own notes, so I'm sure there's some good stuff out there. I wouldn't know. Well, multivariate techniques, if that's a little bit more advanced. Yeah, I don't know if I have anything offhand. Any Google search I would do, you could do just as easily. R programming, yeah. I think the one that I used was never mind. That's pretty good, to be honest with you. This is what I was told to use when I started, way back. So it's this bit right here. See it? By Peter Dalgaard, Statistics and Computing, Introduction with R. So that's what I used. It was pretty decent, but I'm sure, without putting any shame on this thing, I'm sure there's better, and there's worse, of course. So your guess is as good as mine. So I couldn't help as much on that one. I mean, a lot of good stuff is out there, so I don't know that I'd be able to distinguish one over the other. So hopefully that helps. All right, my friend, take care, and it's nice hearing from you.